Okay, so now we're going to use proportions. Today we're going to talk about similar figures, primarily. So similar figures are figures that have the same shape, which means their angles are all the same, but different sizes, which means their sides aren't equal. They are proportional. Corresponding sides would be sides of two similar figures in the same position. Corresponding angles would be angles of two similar figures in the same position. Corresponding angles are congruent, or equal to each other. We'll also be dealing with some indirect measurement today, which is using right triangles to solve a problem. You'll see that when we get to it. And scale factor, just to review, it's the result of multiplying all sides of one figure by the same value. So for example, if you double something, the scale factor is 2. First item on the agenda, find the missing measurement. Each pair of figures are similar, which means their sides are proportional. So there's a couple different ways you could do these. Okay. You could, for this first pair, say, okay, the 12 and the 3 are in the same position. The 20 and the x are in the same position, so I'm going to do 12 over 20 equals 3 over x. That's fine. When you cross multiply and divide, you get 12x equals 60 and x equals 5. It's not the only way you can do it. You could also do 12 over 3 equals 20 over x. Do blue from left over blue from right, and green from left over green from right. When you cross multiply and divide here, you get 12x equals 60. And x is still 5 when 12x equals 60. Multiple ways to set up the same problem. So on this next guy, 9 and x are in the same relative position. 6 and 14 are in the same relative position. You may be wondering, so how can I set these up wrong? How could I make a mistake here? If you highlight the things that are in the same relative position, the one way you cannot set up the proportion is so that they are diagonal from each other. Okay, looking back at the triangles real fast, like 12 and 3 were in the same position. So they can either both be top, or they can both be on one side of the proportion, but they can't be diagonal from each other. So let's say we wanted to go with green over blue. Change of pace, green over blue. So for the first rectangle, green over blue is 9 over 6. For the second, it is x over 14. That's fine, green over blue, just so long as you are consistent. Cross multiply and divide. 6 times x is 6x. 9 times 14 is 126. And 126 divided by 6 is 21. For the pentagons here, 6 and 15 are in the same relative position. 2 and x are in the same relative position. So you know what? Let's do blue over blue. So we'll do right over, how about left over right, 6 over 15, equals left over right, 2 over x. These are all valid ways of setting these up. Cross multiply and divide, 6x equals 30, x equals 5. So those are proportions with similar figures. Now we're going to do some indirect measurement. So a totem pole casts a shadow. Shadow is 45 feet. At the same time, a 6-foot tall dude casts a 3-foot tall or 3-foot long shadow. Write and solve a proportion to find the height of the totem pole. This is indirect measurement. Here's a right triangle, here's a right triangle. We don't know the height of the totem pole. Now I've just set it up so that we have the same kind of things we had before. We can do blues and greens. Okay. So here, and you'll understand why in the next problem, I'm going to set it up as blue over green equals blue over green. And now we can cross multiply and divide. 3 times x is 3x. 6 times 45 is 270. When you divide by 3, x is 90. But some of you, I know right away, are going to be, I don't want to draw a triangle every time. That's fine. Can always set these up as height over shadow. A forest ranger who is 150 centimeters tall casts a 45 centimeter shadow, his height over his shadow, equals a nearby tree casts a 195 centimeter shadow. We don't know the tree's height. Height over shadow. This is fine. Cross multiply and divide. 45 times x is 45x. 150 times 195 is a job for my calculator. That's 29,250. And dividing that by 45 is also a job for my calculator. The answer is 650. We're just setting up proportions, cross-multiplying and dividing. Okay. Every dimension of a 2x4 rectangle is multiplied by 2 to form a similar rectangle. Which means we had 2x4, and now we have 4x8. So this is the original, this is new. Directions here say find the perimeter and area of the new rectangle, but my continued example says find the perimeter and area of the original, so may as well do them both right now, right? So the perimeter of the original is 2 plus 4 plus 2 plus 4. Remember, these other sides that aren't labeled have the same measurements. They're rectangles. So 2 plus 4 is 8. 6 plus 2 plus 4 is another 6, so the perimeter here is 12. The area is just length times width. 2 times 4 is 8. On the new guy, perimeter is 4 plus 8 is 12. 4 plus 8 is 12. 2 12s is 24. The new area is 4 times 8, which is 32. How did those change because we doubled? How did those change? Make sure this isn't huge. So what changed here? The perimeter doubled. The area quadrupled. To figure that out, you take the new perimeter divided by the old perimeter. New area divided by the old area. The question is, why is this true? Okay, so I'll try to make this as simple as I can. I'm going to scroll down for this, because it really can be very, very simple. So if you have a multiplier for all the dimensions of something, and it is x, then the perimeter will be multiplied by x. In the above example, we doubled everything, so the perimeter was doubled. Any kind of area, so area, or if we're doing three-dimensional shapes, surface area, will be multiplied by x squared. In the above example, we were multiplying by 2, so areas would be affected by 4. 2 squared is 4. And volume, if we were dealing with three dimensionals, would be multiplied by x cubed. So if I had a rectangular prism, and I found its volume, and then I doubled all the sides, I would actually be multiplying the volume by 8 to cubed.